Okay, so the inverse and the symbol for inverse is this, which you've seen before when you've done something like sine inverse, right? The little -1 symbol. So the inverse function. So what happens to a coordinate xy when you do an inverse to it? It becomes yx. So I'm doing a switch. Okay, so let's pretend a point was 5, 8. Where would you change the point to? -8, 5. What if you had the coordinate 6, 6? What would it become? 6, 6. Ooh, that's special. We learned a fun word yesterday. When something doesn't change, what is that fun word? Invariant. And the coordinate 3, 1 would become 1, 3. Okay, so that's what an inverse function does. It switches x and y. Okay, so this is a function, and then we're going to graph the inverse function over here. So what I'm going to do is I'm going to label some coordinates. So this coordinate would be 5, 0. So what would it become? 0, 5. I'll take this coordinate, which is 3, -3. And I would be plotting it on that graph at -3, 3. Then I'm going to go with a 1, 0. And when I move it, it will be 0, 1. And I'm going to take one more coordinate, and right at the very end of the arrow there, I'm going to grab -1, 3. So it will be 3, -1. Okay, so here's something. I had somebody who almost got 100% on a provincial exam, and here's what they did wrong. They graphed all these coordinates and then they connected the dots wrong. Okay, so how do you connect these dots? So here's what I would think about. This coordinate has the arrow on it. So which coordinate would have the arrow on it? This one has to have the arrow on it. So it would look like that. Okay, we're going to do some domain and range stuff. So can you write me the domain and range of the first original graph, the f of x? So the domain left is -infinity to the most right being 5. Range, the lowest is -3 to the highest infinity. Okay, so go over here. Can you tell me what the domain and the range is on this graph? The inverse graph. So the domain, the most left is -3, to the most right is infinity. Range, the lowest to the highest. And do you notice anything? They switch places. The domain of this is the same as the range of that. The range of this is the domain of that. And why are they switching domain and range? Because x and y are switching. right? That's the whole inverse idea. If x and y switch, the domain and range switch. Okay, so here's me graphing a function and its inverse. So it's already graphed for you. And what I want you to do is draw the line y equals x. So how do you draw that line? That's a grade 10 concept. How do you draw y equals x? What's the y-intercept of this line? Y equals mx plus b. What's the y-intercept? 0. There's no number there, so it's 0. And what is the slope? 1, which is a fraction 1 over 1. So how do you draw a line that has a y-intercept of 0 and a slope of 1? So that's the line y equals x. So do you notice anything about my function and its inverse? It reflected over that line. Do you see? So if we think back to this one now, if we flip this diagonally, would it end up looking like that? Does that make sense? Diagonally reflecting. Can you visualize that? Right? You can see my arrow was kind of this way, and now it's this way, right? You see the diagonal reflection of it. Okay, so reflected over y equals x, inverse, diagonal reflection. Those all mean the same thing. Reflecting over the y equals x line, and doing an inverse, diagonally reflection. So instructions on your provincial exam questions in your booklet when you're practicing, they could say this, they could say that, they could say that. They all are doing the same thing. Okay, making equations for inverses. Okay, so the original equation is y equals 3x plus 2. So f of x is just the label of your y, basically, right? F of x is your output, which is your y. So if that's my original, we are now going to apply the inverse. So what is the definition of an inverse again? You need to switch x and y. So if I do that, that's the new equation. Okay. Now, the next step would be I need to get y equals out of that. So you need to figure out that y. So would you be okay if I subtracted to 2? Subtract the 2? And I would divide by 3. And this is good work, but now we will just lose points because of our notation. So the final thing says write the equation for f inverse function. So we would just have to make sure we now label it back to the just labeling parts of it. Okay? So switch x and y, solve for the new y equals. Okay, so same idea here. Let's just, obviously f of x, that's the same thing as a y. So y equals this. So let's change the letters. Inverse says switch x and y. So x equals y minus 2 over 5. Okay, apply the inverse, so get the switch. Now I need a y equals out of this. So get me your algebra moves. What are you going to do algebraically? Times by 5. And add 2. And then you have a y equals equation. Okay? Fancy writing would now say the inverse equation equals this. Okay, something you learned in grade 10, or you were supposed to. I was trying to think the other day. I don't think I taught you in grade 10, right? I didn't have anybody in grade 10. So now I don't know. Hopefully you learned this. What does this mean when you have f of something in brackets? What does that tell you to do? You need to input that into the function. That's what it means. So if I want to figure out f inverse of negative 3, I'm going to input a negative 3 instead of an x. So I just added one more step onto what we did, basically. So inverse, switch, make a new y equals equation, and then this just is an extra question about inputting. Okay, so we already know this relationship. The domain of the function is the range of the inverse, and the range of the function is the domain of the inverse, right? They just switch places. X and y switch, therefore domain and range get switched. That's what's going on. Okay, write the domain of the inverse function. Okay, so people that I see on a test do way too much work on this. Okay, the domain of its inverse will equal the range of the original. The domain of the inverse will be whatever the original range was, right? So what is the range of this graph? What's the lowest to the highest? -2 to infinity is the range of that one, which would now end up turning into the domain of the inverse. Okay? So on a test, that shouldn't be a hard overthought question. You just have to understand that relationship. Okay. Write the range of the inverse. So the range of the inverse will equal the domain of the original. Okay? domain, the domain is the x values, right? Domain is x values. So this question is different in the sense that I don't have a graph. Here's what I want to do. I want to list a set of x values. So these brackets in math mean just list a set. They're fancy brackets. How's the drawing on those? I go like this. Ooh. I will not judge your brackets. If you are like this, whatever, squiggly, squiggly. Okay. So I'm going to make...
I'm going to get a mark off for drawing that wrong.
No, I will not judge your brackets.
Well, what if it looks like a square bracket?
Well, if it looks square, then you're telling me it's an interval, which is wrong. Yeah. So squiggly brackets in math mean just listing a few things. So the domain of the original contains those items. So my range will have those items. And what I'm going to do is I'm going to list them as a, what do you want? In order, like that. Okay? If you wrote me 9, 2, and -1, would I mark you wrong? No. If you write me, this is the most common mistake. People write from -1 to 9. This is wrong. Because when you write that, it means you're including every single number between that zone. And you're not. You're just this number, and this number. That's it. Okay, last idea of inverse. Back to grade 10. Tell me, did you ever hear about a vertical line test in grade 10?
Yep.
Did you ever learn about boyfriend-girlfriend rules?
Boyfriend?
Boyfriends and girlfriends rules? No. Okay. Did you know that, okay, we're going to call X, that's a boy, and Y is a girl. Did you know that a boy is not allowed to have, sorry, I'm going to go. A boy is not allowed to have 2 girlfriends.
What?
Sorry. What? So surprising.
Would be a problem for you.
Come on, Brownie. Yeah,
Not allowed. Boys can't have 2 girlfriends. And a girl is.
Oh, come on, that ain't
A girl is allowed to have 2 boyfriends. That's okay.
What?
Okay. So what does that mean? Okay, when I look at this graph, this boy, whatever this X value is, this boy has this one girlfriend and this second girlfriend. That is not allowed in graphing, which makes it not a function. This is not a function. Okay, so it's called a vertical line test. If you ever do this with your pencil and you hit something twice, that's a fail. That's a spot where you have two going on, 2 girlfriends. Okay, this is a function, so this is not, and this one is, because there's never a spot where I'm touching twice. Okay? Did you notice there would have been these 2 girls, right, would have the same. This girl has 2 boyfriends, but that's okay. this y value has two x values. But that's okay, because it passes that. Okay, so what does a one-to-one function mean? A one-to-one function, it would pass the vertical and a horizontal line test, which would mean every x only would have one y to it, and every y would only have one x. There's nobody here that's having two boyfriends or two girlfriends. That's a one-to-one. So for that one-to-one to happen, you would have to pass both tests. Okay, so here's a parabola. A parabola is a function, because if I ever move through a parabola, look at this. If I move through a parabola, I'm okay, right? The parabola doesn't pass the horizontal, which means this. If a parabola doesn't pass a horizontal test, its inverse won't pass a vertical test. X and Y switch, horizontal, vertical switch. Okay, so what do I know? If the function fails a horizontal test, that switches to the inverse failing a vertical test, which means my inverse is now not a function. Do you see this drawing of this sideways parabola? That's not a function. Okay, you ready? Give this equation. Write the equation for the inverse. Okay, so y equals, we're going to switch. X equals, we're going to times by 5. And then we're going to square root. What happens, you've done this in the past, what could you square to get something? You could do a plus or a minus. Okay, so what does this is a parabola. So when I inverse the parabola, I'm going to have the plus square root and the minus square root of it. And what happens to this? That's not a function, right? So we can't do both streams. So what I'm going to do is, it says for x above 0, I'm going to take off the negative one. So my equation could only contain one of them, because it's for x above 0. Okay, so this one. Restrict the domain to make sure the inverse is a function. So what do I have to do? I can either take this side of it, or I can take this side of it. Okay? Again, if you inversed it, it would look like this, which is not a function. This is not a function. So you could either take that part of it, or you could take that part of it. So how do you write the domain if you want to make sure you're only taking one half of it? So if you picked the pink half to inverse, what's the domain on that part? Negative infinity, 2, 3.
Yeah.
And if you picked the yellow half, you would be 3 to infinity. So you can only pick one half of it so that when it inverses, okay, look at the one half, it would inverse and clear the test. Inverse. Done.
Boom.
Oh.